All right, good afternoon. You're welcome. Um, I can see you, talented. Good afternoon. You're welcome. Okay, so sorry for the little delay. So we are going to start immediately. All right, so this was where we stopped in the last class. We stopped in this particular example or exercise, and I gave as an exercise to you all to try to attempt it and to produce what it will look like while we went for a break. Personally, I only went to rest small. Okay, so I didn't really look at it. So like I told you earlier in this class, so this lesson is going to be strictly unscripted. I'm not going to be looking at any of the questions or whatever before starting the class. The reason is because I want us to walk through it together. Okay, so that's why I'm actually doing that. Okay, so let's begin. So what do we do with here? I want us to look at this example before we will now go to the 17. Remember I said we will now go through 17 to 32. Okay, so what is expected of us here? We have that the cube root of 8a raised to power 3 b raised to power 6 is divided by this and multiplied by this. Okay, so we may choose to rewrite them and bring the one that is dividing down. Maybe that's what we'll do. Or we can also leave everything like this and still do our work. Anyone. Okay, so first of all, it will be good to change this square root to a power, cube root to a power of 1 over 3. So this will be 8a. Okay, meanwhile, we can also change our 8 to 2 raised to power 3. Then this one is a to the power of 3, and then b to the power of 6, and everything is raised to the power of 1 over 3. Okay, so I wouldn't know which one you prefer. Should I bring this down? Okay, what should I do? All right, we may leave it this way. Let's go. So this is going to be divided by, now square root means power half. So I'm going to bring it up. Now, but before we go, 1 over 25 is the same thing as 1 over 5 all squared. So I'm going to be writing it that way. 1 over 5 raised to power 2. Then by 4 power a power 4, and then b power 8. Okay, so we can close here and raise it to the power of half. Then multiplied by, this will be 16. Now here we will have square root is also power half. So this will be 4, So this is going to be a to the power of 4, then b to the power of 6, all raised to the power of half. Now meanwhile, there is an outer power here. There is an external power here, which is half. So let me also use that block bracket here. Okay, so this is a block bracket. Let me use it. Okay, so now we can now move on. So what do we do here? Okay, so we try to clear our brackets. I think that should be the best thing to do now. So to clear the brackets, all the powers will come in to multiply the existing powers. Okay, we didn't do the same thing we did to all other numbers on 16. So please, let's change 16 to 4 to the power of 2. Why did I choose power 3 here and power 2 in these other two places? Because of the already existing power half, and this one is power 1 over 3, so it can cancel out. So this power 1 over 3 will now come in to multiply all the powers, and when it multiplies this one, you get only 2. When it multiplies a, you get only a. When it multiplies b, you get b to the power of 2, because 3 will cancel 6, and then you will have 2 left. Now divided by, here you will now have half will cancel these 2, you have only 1 over 5. Then it will cancel 4, you have power 2. It will cancel 8, you have power 4. Multiplied by, finally here, half will cancel half, you have only 4. and the half will cancel this other half. Remember that this other half is on this A and B. So it is either you open this bracket and this half cancels this, and then this one now cancels again. But you can actually open this, and then this half will multiply this half, and it will be power 4. Then you can now use the power 4 to, it will be power 1 over 4, because half times half is 1 over 4. Then you can use that 1 over 4 to now multiply here, and your A will just be only A, and your B will be 6 over 4, because 6 times 1 over 4 will be 6 over 4. So 2 here will give 3 over 2. So we can write our B as 3 over 2. Okay. So having done that, what can we do next? So we can now begin to multiply and divide where necessary. So first of all, we are going to, you remember I said numbers will divide and multiply numbers, alphabets will divide and multiply alphabets. So 2 will be divided by 1 over 5 and be multiplied by 4. So if 2 is divided by 1 over 5, let me put it this way, 1 over 5 and multiplied by 4. This is the same thing as 2 times. If we change this will turn into 5 over 1, then times 4, which is actually going to give us 40. So all the numbers will turn to 40. So when the numbers turn to 40, we will now have for A now. Let me use blue for A. So what are we going to do in A? Remember that for A, the powers are just going, we only use the powers. So for instance, the power of A here is 1, and this one is division. So it's going to be minus the power of A here, which is 2. Then this is multiplication, that is plus the power of A, which is 3 over 2. So we are done with A, and then finally we go for B, and B is going to be, the power of B here is 2, and the power of B here is 4, and this one is division, so that will be minus 4, and the last one is multiplication, that will be plus 3 over 2. So remember in indices, the powers will add if you are multiplying, and it will subtract if you are dividing. Okay, quickly let's now finish our addition of powers. So we have fractions in all of these. For your A, I made a mistake here. For A, the last power is 1, not 3 over 2. That 3 over 2 is the power of B. Sorry about that. So I'm talking about this. The last power there is 1. Okay, so what we are going to have now is 40, then A to the power of 1 minus 2 plus 1. That is 0. And then B, so let's do this fraction here. 2 minus 4 is minus 2. So we have minus 2 plus 3 over 2. Okay, which is, let's do minus 2 over 1. So LCM is 2. And this is going to be minus 4 plus 2 into 2 is 1. 1 into 3 is 3. So you will have minus 4 plus 3 is minus 1 all over 2. So our B is power minus half. Wow, this is beautiful. This is very beautiful. And so our final answer, of course, A will go because A to the power of 0 is 1. So it will leave the expression. So we'll just have 40B raised to the power of half. Remember that you can actually write this in other forms, which is what I keep telling us, that when it comes to exams, you can actually solve and get the correct answer, and then that answer will not be in the options. The reason is because we can write your answer in different forms. So this 40B raised to power minus half can actually be written as 40 all over B raised to power plus half. Why? Because power minus half is the same thing as 1 over B raised to power positive half. I hope you are following me now. Okay, so you can leave it this way, or there is another third form that it can take. And what is that? The power of half is the same thing as square root. So I can write this as 40 all over the square root of B. So depending on what your options are, any of these three is a solution to this example. And that is what we have for exercise 16, which I gave you as an exercise to do, and I don't know how many of you did. Okay, so, and that's the end of the first half of this solving of exercises, and now, so we go over to the next section now, so which is from question 17 to 32. Let's also see how far we can go with that. So we begin with 17 now. So if you watch, I said that the problem solving for this exercise continues. Okay, so we are beginning with 17. Now, the general question for 17 down says solve, let me write it, solve for x in each of the following. Solve for x in each of the following. Alright, so in each of the following equations actually. Alright, so but whether we put equation or not, Okay, so, and then it started with 17. So the implication is that everything we are going to get from number 17 down now are going to be equations. Okay, let's go. So the first one is 1 over 5 all raised to the power of 2x minus 3 all equal to 625. Okay, so this now has to do with exponential equations, which we can also call indicial equations. Very beautiful. And like I would always say, I said that in the last video, that one rule that you must keep in front of your mind when it comes to exponential equation is a rule that says that if I have a to the power of n to be equal to a to the power of m, once the bases are the same, then the powers are also equal. So if you have this rule in front of your mind, not at the back of your mind, it will help you a lot when it comes to solving equations involving exponents. Of course, it will also involve all other rules of indices in the process. So, but this is very important. Okay, so let's begin. Solution. For number 17, what do we do here? So first of all, what we have here is 1 over 5, and on the right hand side we have 625. The question is it possible to write 1 over 5 and 625 to be in the same base so that I can apply this rule here? And the answer is yes. What is 1 over 5? 1 over 5 in base 5 is the same thing as 5 to the power of minus 1. And then remember what we said in one of the rules: when there is already an existing power and you're bringing in another power, the both powers will multiply. So minus 1 is going to multiply 2x minus 3. Right? Beautiful. So we move to the right hand side. What is 625 in base 5? That is 5 to the power of 4. Okay? Because 625 is actually the square of 25. And 25 is 5 squared. So you're having 5 squared times 5 squared. This is how to get your exponential numbers. You don't need to know all of them. Just know a little thing, about them. It can actually help you hasten whatever you want. So from the multiplication rule, I will just pick 5 and then add 2 plus 2. That's how I got this 5 raised to the power of 4. Okay? Let's move on. So from here now, immediately you can now take away the equal basis, and so your powers now become equal. So here I can go straight and open the bracket. Minus 1 times 2x is minus 2x, and minus 1 times 3 is plus 3, and the whole thing is equal to 4. So my job now is to look for x, which is actually what I was asked to do from the beginning. Okay, so I can take my 3 to the other side, and that will be 4 minus 3, which is 1. Finally, my x is equal to 1 over minus 2, which is minus half. And that is the solution to exercise 17. And I hope that made sense. I hope it's beautiful. Now remember, the essence of this series that I began doing on this channel is to lead you to solve many exercises. I tell you, I know I've said it before. In solving exercises, you solve your exam questions with no matter what the exam is. The key is solve exercises. You get to know different type of modes that questions can take in a particular topic, and that's why we started this series yesterday by solving the exercise 1.5 of this book, which had 30 questions, and we finished it in that video. So here we are doing 32 today. So let's go on. This is for 17. Let's try to go to 18 now. Okay, number 18 says you are given 6 to the power of x plus 2. Everything is equal to 216. This one is very cheap. I should allow you, handle it. Of course, all of the questions are easy. Once you get the steps, you can easily continue what you're doing. And one thing you should know about maths is that most maths questions will always give you a clue. So if you look at the left hand side now, you see the base is 6. So what you should be asking yourself is, this 216, is it possible to be in base 6? The base of the left hand side has already given you a clue of what to do on the right hand side. And so immediately I can see that yes, you can write 216 in base 6. And that I think is 6 to the power of 3. Try it. That's 6 times 6 is 36. Multiply 36 by 6 again. Yes, I think you will get 216. And you are done. The equal basis will leave the equation. And so you have x plus 2 is equal to 3. Therefore, your x alone is equal to 1. If you take your 2 to the other side of the equation. Exercise 18 is done. So we move over to the next one, which is exercise 19. Okay, so for 19, we are given something similar again. 1 all over 15 all raised to the power of 3x is equated to 225. Is equated to 225. Okay, so I can allow you to try all of these, and then let me see what you can get. Do number 19. Yes, I'm making that decision. Do 19. Let me see in the comment section what you got as the value of x for this number 19. Of course, you should get something. A hint here, like I said in number 18, is that this 6, which is the base on the left hand side, has given you a clue about what should be the base on the right hand side. Even though it's not always the same, but it is always, most times it takes that shape. Okay, so look at this. You have 1 over 15. Of course, you can write 1 over 15 in base 15. So that means you should check 225 in base 15. Okay, so let's go to 20. 20 says 4 is raised to the power of 2x, and it is divided by another 4 to the power of 3x is equal to 2. Okay, so this is equated to 2, and then yet again we are looking for the value of x. This is also very simple. So apply the rule of indices first on the on the left hand side. If I do that, I will have they have common base, which is 4. So I will now subtract their power since it is division, and this is equal to 2. Then I will ask now, can I write both sides to be on the same base? Yes, I can actually write 4 in base 2, which will give me 2 to the power of 2, and that 2 will multiply the existing power, which is 2x minus 3x, and that is equal to 2 to the power of 1. Your right hand side will be 2 to the power of 1. Okay, so I have some solutions over here. Yeah, Chukun also says minus 2 over 3. That's for number 19. Okay, I'm waiting for any other person who has a solution. Okay, let me try to peep into it. Yes. Oh, beautiful. Let me wait for others, but I think that's very correct. Yeah, that's very correct. Minus 2 over 3 is correct. Okay, yeah, I have Choma Princess. Yes, that's okay. Minus 2 over 3. If you do it properly, you should get that. Yes, you should. Yes, you should get that. Okay, let's move on. So the next one now we have, okay, now all we need to do again now is to now bring out our powers, because the bases are now equal. So from here I can quickly multiply, and that will give me 4x minus 6x is equal to 1. I've removed the equal bases now, and then you are done. 4x minus 6x is equal to minus 2x, and so is equal to 1. Therefore, your x alone is minus 1 all over 2. Okay, maybe we should touch this together. Yeah, Ife said minus 2 over 3. That's beautiful. Okay, so maybe we should touch this together. Remember that 1 over 15 is 15 to the power of minus 1, and minus 1 will multiply your existing power, which is 3x, and 225 is 15 to the power of 2. So if you take away the equal bases, you will have minus 3x is equal to 2. So this is just something you can do in one line, and so you have minus 2 all over 3 if you divide both sides by minus 3. Okay, so and that's for number 20. We move on now. Okay, so we go to number 21. Is here. You are given 7 raised to the power of x plus 2 divided by 9 raised to the power of x minus 1. Sorry, it's not minus, plus 1 is equal to 3 raised to the power of 2x. Okay, we are looking for x again. So now, please, as we are going, you'll be trying it and be letting me know what you got. Okay, so while I continue, because of course it's all about getting a nice solution, so I would like to be seeing what you're doing with it. Okay, so what do we do here? We will try to put everything across in the same base, and 3 is the most possible base that all of them can take. So I can write, this should be implied, so I can write 27 as 3 to the power of 3, and it will multiply x plus 2, divided by, I can write 9 as 3 to the power of 2, and it's multiplying x plus 1, and this is equal to 3 to the power of 2x. Alright, so here you will now have, what is that going to give you? Division is subtraction of powers, so I will have 3 raised to the power of 3 into x plus 2 minus 2 into x plus 1, and everything is equal to 3 to the power of 2x, and you are done. So what should you do next? Equal bases can go, and so from here we can now have the powers to equate, and so I can open those brackets. This will give me 3x plus 6 minus, this one will give me minus 2x, and minus 2 times 1 is minus 2, and that is equal to 2x. And that's going to give us, so let's collect like terms now. So we have 3x minus 2x is x, and then 6 minus 2 is 4, and that's equal to 2x. Okay, we can actually bring over our 2x to this side, and that will be minus 2x equal to 0. Okay, and then x minus 2x is minus x. Anyway, you can actually see that bringing over this 2x is not the best, so we could have actually taken x to the other side. Okay, so here if we take our 4 this way, it will be negative 4. However, both of them will give you the same answer actually. So minus will cancel minus, our x will be equal to 4. So we have 4 for example. Yes, yeah, Chukunon, so yes, you are correct. 4 is correct. Yes, 4 is correct. Okay, so let's go on to the next example. Yeah, we have, that's number 21 or 22 now. Okay, number 22. Okay, so here we are given 8 to the power of x over 2 is to be equal to 2 raised to the power of 3 over 8, and that is multiplied by 4 raised to the power of 3 over 4. Okay, and you of course remember we are looking for x in all of these, so what will be the value for our x? Okay, so other topics are not easy over here. Okay, don't worry, after this particular exercise I will be moving, but you can be writing in the comment section other topics that you want me to look at. Okay, so we can, the approach I want us to be using now is this approach of exercises to solve problems. Okay, or to begin to use exercises to learn different concepts instead of just taking our time to be looking at the topics and all that. Let's just use exercises to be learning them. So you can type here the topics you want us, maybe in the next section of our live class I will go to those topics, use exercises there, and then we will move on. Okay, so let's go here. So here everything should go to base 2. I think that would be nice. So we are going to have 2 to the power of 3, and that 3 will multiply this, so which will give us 3x over 2 is equal to, on this side this one is already in base 2, so multiplied by the second one is, you are welcome also. The second one is 2 to the power of 2, so that 2 will multiply 3 over 4. Okay, so what is that going to be? Return this the way it is first of all, so that we can simplify the right hand side first. So we have power 3x over 2 is equal to, okay, so that is equal to, here 2 will cancel 2 here to give you 3 over 2. Okay, so 3 over 2 is left here. So this will be power 3 over 8 multiplied by power 3 over 2, which is addition. Okay, so we are adding power 3 all over 2. Okay, so let's continue here. This is going to give us, so at this time we can actually remove the equal basis, and when we do that we will have 3x over 2 is equal to, so here we have 3 over 8 plus 3 over 2. LCM is 8. Of course you need to simplify the fraction. Our LCM is 8, and 8 into 8 is 1, times 3 is 3, plus 2 into 8 is 4, times 3 is 12. Alright, so here we have 3x all over 2 is equal to this. Okay, so we can actually add that numerator, and if we do, we are going to get 15. So let me add it. 12 plus 3 is 15. Beautiful. So we cross multiply, and that's going to give us 3x times 8, which is 24x, is equal to 30. And finally our x is equal to 30 over 24. And 30 over 24, you can reduce it further to give you, if you divide by 6, you get 5 all over 4 as the solution, which you can as well write as one whole number 1 over 4. And that is for exercise 22. That is for exercise 22. And so we can now move on to the next one, which is 23. Okay, 23 says, okay, so number 23 says that we are given 5 to the power of 2 into x minus 1, and that is multiplied by 5 to the power of x plus 1, and that is equal to 0.04. Okay, so this particular example leads us to something that looks like quadratic equation. Why did I say this? Because I've been solving problems on this. I remember that the year I wanted to take my entrance exam into the university, that should be 2009, 2010. Someone gave me a question like this. And just like what I'm telling you, we were just discussing. He said, what do you want to study? I say maths. And then he said he wants to test me. So he gave me a question in this form. and it happened that a day to that day I actually studied and saw something like this and then solved the exercises on it, and so it was easy to actually handle that particular example. Okay, so although this one now here is multiplication, assuming it was addition, then it will lead us to quadratic equation. But let's see what this is going to be. Okay, so let's go. Here we have equal basis, so all we need to do is to already apply the rule. So we have 5 raised to the power of you can open this bracket immediately, so you have 2x minus 2. Then you are adding, because there is multiplication here, and if we add the power here, it will be x plus 1. So we have plus x plus 1, and that is equal to, the left hand side is a decimal number. Remember, as I will always say, change it to fraction. And if you can actually do it somewhere, okay, if we change that to fraction here, that will be 4 all over 100. Remember how I said you write your 4 all over 1, then you count the number of digits after the decimal point, and here we have 0.4, which is 2. So you add 0 here. Now we will try to reduce this to the lowest term, and that will give us 1 over 25. And you can clearly see that 1 over 25 can actually be written in index form with the base as 5. That's how beautiful math problems are. We will always give you something that will be nice if you get it. Okay, so this is going to be 1 over 5 raised to power 2, and we know that 1 over 5 raised to power 2 is the same thing as 5 raised to power minus 2, and you are done. Take away equal basis, so here we have 2x plus x is 3x, minus 2 plus 1 is minus 1, and that is equal to minus 2. Take your minus 1 to this side, we will have 3x is equal to minus 2 plus 1, because minus 1 will change to plus 1, and that is equal to minus 1. And so your answer is x is equal to minus 1 over 3. Minus 1 over 3. And that's the solution for 23. Okay, so we move on. If you have any question, you can drop them as we move on. Okay, so let's go to the next thing. And what is that? Which is number 24. Okay. Okay, number 24 says that we should, of course, we are still looking for x here, and there are 2 of them here. So I will write the first one. Here we are giving 5 to the power, 5x, to the power of 2 over 3 is only the x that is raised to a power, is equal to 80. And we are to get our x. This is a very beautiful example. What do? So this 5, you can clear it out from here, because it's not going to help you, because it doesn't have any business to do with this power. So you need to clear it out from here. And how do you do that? Divide both sides by 5. So you will have x to the power of 2 over 3 is equal to 80 over 5. I think is 16. Am I correct? 16 times 5 is 80. Yes, I'm correct. So you have 16. Okay, and then you will now try to clear the power that is already here. How do you do that? First of all, you can raise both sides to the power of half. I actually know what to do, but I'm just trying the best way to explain it to you. So you can raise both sides to the power of half, so that you can clear the power 2 here. So if I raise, this is 2 over 3. If I raise it to power half, so the half will multiply the existing power. And if I raise 16 to the power of half, that's square root. Okay, so this is going to give me the half here. Will remove these 2. So you just have x to the power of 1 over 3 is equal to the square root of 16 is 4. Okay, so our x alone, you can now bring in this power. Another way you can do it is also to multiply or to raise both sides to power 3. So if you raise here to power 3, 3 will multiply. Why did I raise to power 3? Because I'm trying my best to cancel out this, the fractional power that we have here. So, but the only thing is that, excuse me, if you do it to the left, math rule says you must also do it to the right. So I will also raise 4 to the power of 3. And so this 3 will cancel this 3, and my x will stand alone. So therefore, my x is 4 to the power of 3, which is the same thing as 64. 4 to the power 2 is 16. So if you multiply it again by 4, you will get 64. Right. So, and that is the solution for number 24. Okay, which is number 24I. Okay, look at the II. I'm thinking of leaving that for you as an exercise. Let me see. 3 raised to the power x minus 1 multiplied by 2 raised to the power of x minus 1 again is equal to 1. Wow, I think I like this example. This example, you can actually do it in one line. Yes, and what is it? Very beautiful. What rule are you going to apply here? The rule where you have distribution of powers. So you recall I said that if you have a raised to power n times b raised to power n, both of them are raised to the same power. So you can bring in a bracket and put the basis, the product of the basis in the bracket, and then raise the two of them to the same power. So what it means is that if you open up a bracket where there is multiplication, the power would distribute over the terms in that multiplication. So that means this is going to give me, I can bring in 2 times 3 into the bracket. Since both of them have the power x minus 1, I will bring it out of the bracket, and that is equal to 1. Okay, this is the end of my board here before I go to a new page. So let me see if I can finish it here. Yes, I can. And so 2 times 3 is 6. So I have 6 raised to the power of x minus 1, and that is equal to, will I write 1 here on the right hand side? And my answer is no. I need to put this one in index form where the base will be 6. And one of the rules of indices says that any number to the power of 0 is equal to 1. So immediately the bases are the same. So I can, please come up here, let's finish it here. So I can now write that x minus 1 is equal to 0. Therefore, my x is equal to 1. I sincerely like this particular exercise. It's so beautiful. All right, so the value for x in 24II is 1. Okay, so let's move on to a new page, and then we have the next one, which is 25. Remember, we are journeying to 32, and it's a very beautiful journey so far. Okay, so the next one says that 2 is to the power of x is multiplied by 4 to the power of x is multiplied again by 9. Sorry, what did I say? It's multiplied again. Yes, I'm correct. 3 to the power of 3x and is equal to 216. I like this example. I tell you the truth. What do you do here? I was seeing if I could leave it. But yet again, because I like it, I want us to look at it together. So what are you going to do? 2 is to power x, and 4 here is to power 2. To power x. But here you have 3 to power 3x. So what do you think is possible here? There are 2 things I am seeing that you can do here. Okay, let's take the first method. Okay, so the first method is that I can write all these things to have power x. How? This is going to give me 2 to the power of x multiplied by 4 to the power of x. Now, my 3 is raised to the power of 3x. I can actually bring in that 3 here, and that is in form of 3 to power x, and raise everything to power, 3 to power 3 and raise everything to power x. Because by the rule, if I remove these brackets, 3 will still multiply this x to give me 3x. So but why did I do this? So that I can write 3 to power 3 as 27, and then I will only have power x. So that has given me something I am looking for. All of them now have the same power, and so I can bring in a bracket and then do 2 times 4 times 27, and that is equal and that is raised to the power of x equal to 216. Okay, so what do we do from here? So we will now try to see what the value of 2 times 4 times 27 will be. And amazingly, you will not believe it, 2 times 4 times 27 is 216 to the power of x. And you are done. 216 on the right hand side make the power to be 1. Therefore, my x is equal to 1. Wow. I really love these exercises. I really love the exercises. They are so beautiful. Very, very beautiful. Okay. So, and I hope it made sense. Yes. Okay. So what other method did I say we could have attempted? Is it necessary? Okay. Let's leave it. But then it's possible to do other things. Let me see. For instance, we can actually put 2 to the power of x, and here I'll have 2 to the power of 2x, because 2 will come up and multiply this, and then here I will have 3 to the power of 3x. Yes, I've seen something beautiful now. Okay, and this is giving me 216. You will like this approach. So what's going to happen here? 2 to the power, you have 2 bases in base 2, 2 index numbers in base 2. So you can join the 2 of them. They are multiplying. So this will give you 2 to the power of x plus 2x. Wow. And this is 3x times 3 to the power of 3x. And immediately you can see both of them now have the same powers. So I can now do the distribution of powers by just bringing out the powers and multiplying the bases. So I'll have 2 times 3 all raised to the power of 3x equal to 216. What do you think will be this? So 2 times 3 is 2 raised to power, is 6. And that is 6 raised to power 3x. And I can write 216 in base 6. This is amazing. And that's going to give me 6 to the power of 3. I think we saw it earlier on somewhere. 216 in base 3. Let's check. Yeah, I think we did it somewhere up. 216. Let me see if I can find it. Yes, see it here. Exercise 18. Yes, we saw it there. That 216 is actually 6 in base 3. I love this. And immediately the basis will go away. So you have 3x is equal to 3. And here again, you will get your x as 1 if you divide both sides by 3. This is why I love maths personally. It is not stereotyped. It doesn't constrain you into one box like that. All you need to do is just think. Your thought pattern may be different from what I'm thinking, but the beautiful thing is that once it follows or aligns to the rules of that concept, both of us will get the same answer, no matter the steps we took. So the only thing is that our steps might be different, but once they are logically correct, according to the rules of the topic, we will land in the same place. This is amazing. I think I need some clap here. Please give some emojis, some. Okay, so let's go on to number 26. All right, number 26 on our exercise. Remember, we are still dealing with exercise 1.6. And it's unscripted. We are just solving from the book. And the reason, like I said, is so that we'll look at it together. And that's why, like we saw in this number 25, we had to use different methods so that you can see what is possible. Okay, so we move to 26. 4 to the power of x, all multiplied by 3 to the power of x, is equal to 1728. Now you can see this number is now a bit large. But like I told you, of course, the powers are the same. So if you bring the powers out, the basis will multiply, and that will give you 12 raised to the power of x is equal to 1728. So like I told you earlier, the base on the right should always give you a hint to what you can convert the base, the base on the left should give you a hint to what you can convert the base on the right. So let's try it. Our base on the left is 12. So let's multiply 12 by itself. Maybe if you multiply that 12 times 12, you have 144. Let's go again and see if we will get 1728. Beautiful. That's exactly what he gave. You see, if you understand all of these trick in math, you will always catch maths examiners, whenever they give you problems, right? So, of course, 1728 can be expressed in base 12 and is equal to 12 to the power of 3. And you are done. Your x is equal to what? 3. And so for number 26, our value is x equal to 3. Okay? So let's move on to the next one, which is 27. And I can do 27 by the side since there is a space here. Okay? And that is a bit long. Okay, so we have 20 to the power of x minus 1 multiplied by, here we have 5 to the power of x minus 1, and then again times 8 to the power of x, and yet again 125 to the power of x, all equal to 1. Wow. All equal to 1. Okay, so what do we do here? What do they expect from us? Let's try something. Okay, so first of all, notice that the first two have the same power and the last two also have the same power. So what do? You will do your distributivity of power, bring out their powers, multiply their bases. So 20 times 5 is 100. So that will be 100 raised to the power of x minus 1 multiplied by the second one. The bases are 8 and 125. And you have the powers to be the same, xx. So what is 8 times 125? I think that is 1,000. Yes. Yeah. 125 times 2 is 250 times 4. Yes, it's 1,000. So you have 1,000 raised to the power of x. And that is equal to 1. Okay. So what can we do with this? What can we do with this? We can take everything to base 10 if we want. That's one way. So, of course, there are other things you can do. I can actually choose to simplify this into 100 to power x all over 100 multiplied through by 100. But that is a longer process. So, take everything to base 10. 100 in base 10 is 10 to the power of 2. So, that 2 will multiply the existing power. And that's going to give us 2x minus 2 multiplied by 1,000 in base 10 is 10 to the power of 3. And that 3 will multiply the x, which is the existing power. And that will give us 3x. Don't forget to write 1 in base 10. And 1 in base 10 is 10 to the power of 0. Okay? So that is going to give us a very beautiful thing. So multiplication, the base is 10, so we add. So you have 2x minus 2 plus 3x is equal to 10 to the base, to power 0. And so equal bases will disappear. And so we have 2x plus 3x is 5x minus 2 is equal to 0. Beautiful. And you are done. If you take your minus 2 to the other side, you have plus 2. Divide both sides by 5. You will get that x is equal to 2 all over 5. I love this example also. So we have 2 over 5 as the value of x. Okay? So here again, we move to number 28. Alright, 28 says you have 4 to the power of x minus 1. Okay, multiplied by 5 to the power of 2x minus 2. And then everything is equal to 100. Let me show you how mathematics, anyway, I've been showing you that how mathematics examiners think. When they have a concept that they want to ask question around, what they do is that they try to twist the example, but what they want is actually inside that exercise. For instance, look at this. We've been talking about the same power, the same power. The power of the first one is x minus 1. Now, instead of giving you the power of the second one to be x minus 1, this person decided to give you 2x minus 2. But the funny thing is that inside 2x minus 2, you have x minus 1. Okay, so let's go into it. Solution. What do we do? Retain your 4 raised to power x minus 1. Then when you come to 5, you write your 5 to the power of, here you can bring out 2. And that's how you will see it. If you factorize 2, this 2x minus 2 will now be 2 into the bracket of x minus 1. And beautiful, this is equal to 100. So what's going to happen there? And then, like what I did earlier on, I think, let me look for that exercise. Maybe somewhere, okay, because of our time, let's go on. I will just show you here. So I think I touched it somewhere earlier, where let's say you have 3 raised to the power of 2x. I think it was something like this. Okay, it was 3x, power 3x. So you can actually split this into 3 raised to power 2, all in power x, or you can write it as 3 raised to power x, all to power 2, depending on what you want. Because if you remove this bracket, 2 times x will give you 2x. If you remove this one, x times 2 will still give you what? 2x. So depending on what you want. So here, I actually want to get the value of this 5 raised to power 2. So see what I'm going to do. If I do that, that's now going to give me 25. And the power will remain x minus 1. So if I choose to bring back my 25 in index form, it will still give me 5 raised to power 2. And these 2 will still return. I hope you are with me. Yes, I know you are. Okay, so, and that is equal to 100. And already, I am seeing the solution to this problem. I don't know if you are. Yes, I am. So, and how am I seeing it? Bring together by multiplication the bases, since the powers are the same, and then in brackets, bring out the power. And this is equal to 100. And so I'm seeing my x as 2. How did I get that 2? 4 times 25 is 100, raised to the power of x minus 1 is equal to 100. And 100 in index form can be written as 100 to the power of 1. So you take away your equal basis, you will have x minus 1 is equal to 1. Therefore, if you take your minus 1 to the other side, your x will be equal to 2. I really love this example. Okay, so, and that is the solution for exercise 28. We are 4 left. Okay, sorry, we have 4 left. We go to number 29. Okay. Okay, for number 29, we are given, where is it? 2 to the power of x plus 6. Multiplied by 5 to the power of 3x plus 4. This one looks long. I hope it will enter here. Then multiply again by 10 to the power of x. And finally multiplied by 4 to the power of x minus 1. Everything is equal to 1. Now, let me tell you what I mean by unscripted. Unscripted means that I don't even know what the answer for this is because I have not solved it. So we're actually solving this together. And like I said, the essence is so that you will know that you too can begin a problem, solve exercises on your own. You know, try doing something. Okay, so as it is now, I may not really know what the solution is, but I know what to do. And what is it? I will try to look at the values I am giving here. I think I want to move this down to the next line because this may expect that this will be a bit long. Let me try to move this to the next page. Okay. to, yeah, put it on the current page. Why? Where did you put it? Okay. Okay, you wanted me to put it to a new page. Should I do that? Okay. Okay, let's continue. If you didn't, maybe I can clean this part. I don't know. Sorry about that. Maybe I can remove here for the sake of space. I think this will need some space. Okay, so see what we are going to do now. We will retain our 2 to the power of x plus 6. Now, I know somebody will ask me, what do I want to do? I am seeing base 2 here, and I'm seeing base 5. I can't join them, even though it's multiplication, but I can't join 2 and 5 because the bases are different, and the powers are also different, so I can't join them. But I'm seeing base 10 here, and base 4. Two bases are also different, the powers are also different. I can't also join them. But I can split 10 into 2 and 5. And I can turn 4 into base 2. That's actually what I want to do. Okay, so I hope that made sense. Let's go. So this is now going to give me 5 to the power of 3x plus 4. Now in splitting 10, I will get 2 times 5. And why did I split it into 2 times 5? Because I'm already seeing base 2 and 5 here. And so that is to the power of x. And that is multiplied by 4, which is 2 to the power of 2. And that 2 will multiply x minus 1, which is the existing power. And that is to the equal to 1. Okay, so let's move. What is this going to be? So I will now open this bracket to separate the powers. So this will give me 2 to the power of x plus 6 multiplied by 5 to the power of 3x plus 4. So this is going to now give me, the power will come on the two bases here, which will be 2 to the power of x multiplied by 5 to the power of x multiplied by, here you will now have 2 to the power of, open this bracket, which will give you 2x minus 2. I like this example. Yes, I do. Okay, so what is that going to be? When I usually would tell my students, whenever a teacher says we like this example, it's because it's looking challenging, so it's allowing us think. That's why most of us did maths, because maths allows you that opportunity to think. Okay, so now immediately we can now begin to join those with the same base. So I have how many base 2 here? 1, 2, 3. So I'll join them. Since it's multiplication, all their powers we add. So I'll only pick one base to the power of x plus 6 plus the other power, which is x, plus the other power, which is 2x minus 2. Wow, this is nice. Multiplied by, I will now go to 5. 5 has only 2 here. So I will have 5 to the power of 3x plus 4 multiplied by 5 to the power of x. So I will just add only x here, and that is equal to 1. And somebody will ask, why have I carried my 1 like this down to this point? Why didn't I change it to anything base, anything raised to power 0? Because I do not know what to change yet. So I need to get a single base on the left hand side before I can change my 1. I want you to always get, be ahead of every step that you want to take. Now, see what's going to happen here. My mind is telling me that by the time we simplify these powers, that they are going to be the same. Let's see. Okay, so this is 2 to the power of, here we have x plus 2x. That is 4x. And here we have 6 minus 2. And that is plus 4. Oh, God of mercy. Have you seen what I'm saying? That's exactly what we have here. 3x plus x is 4x. Then plus 4. Wow. And this is equal to 1. And why did the person that constructed this question, why did he do this? Because since the bases are different, the only thing is that the power should be the same, so that you can now use distributivity of power to extract the powers and then multiply the bases. Wow. Wow. I hope this is making sense. Okay, let me go on to this side. So this is going to give me, so I will now multiply the bases, and 2 times 5 is 10. So everything is now raised to the power of 4x plus 1. So immediately I can now write my 1 to the base of 10, because I have now seen a base, a single base on the left hand side. So it will be base of 10 to the power of 1. And so equal bases will go away, and my power 4x plus 4 will be equal to 1. And so my 4x alone will be 1 minus 4, which will be minus 3. And therefore, my x is equal to minus 3 all over 4 if you divide both sides by 4. Jesus, this is beautiful. This is a construction of deep thinking. You know, the constructor of this exercise did a good job here. It allows you, the opportunity to think, and I love this. So the solution for number 29 is x equal to minus 1 over 3. And I tell you the truth, if you have not taken time to solve problems that look like this, you will definitely find it difficult to tackle this if this was to be an exam. So this is why you need time to always solve problems when it comes to maths. Okay? Alright, so let's move on to number 30. So number 30, we have 9 raised to the power of x multiplied by 16 to the power of x, and that is equal to 12, and that is 12. So here again we are asked to get the value for x. So what do? You can clearly see the powers are the same, so this one is straightforward. So you gather the bases. 9 times 16 all to the power of x is equal to 12. Okay, so here now we will try to multiply the bases, which is 9 times 16. And let's see, 9 times 16 is 144. Okay, so we have 144 to the power of x is equal to, on the right hand side, we have 12. Beautiful. Okay, so you can see the work is done. So we can write 144 in base 12. And that will give us 12 to the power of 2. These two will multiply the existing x power, which is x, and that's equal to 12 now can be in power 1. And so you take away equal bases, so you just have 2x is equal to 1. Therefore, our x alone is equal to 1 all over 12. So we are just 2 exercises away from completing this section, and my board here is full. So I am going to do just one, and I will leave one as exercise. So let's go to a new page. Okay, number 31 is given as 3 over 4 raised to the power of 2x multiplied by 2 over 3 raised to the power of 2x also is equal to 8. I'm going to leave this as the exercise. I think it will be much simpler than the next one. Okay, let me write the next one. Thank you very much. Okay, all right, let me write the next one. That's number 32. Number 32, which is the last one in this particular exercise, 1.6. Okay, so it says that you have 2 over 3. Okay, as if you knew I needed this thing. Thank you very much. Thank you. Okay. All right. So, okay, so here we have raised to the power of 3x, sorry about that, all over 2. Now it's multiplied by 1 over 6 raised to the power of, my God, here we are given minus 1. And then minus 1 whole number, 1 over 2. Then x is multiplying all of it. Wow, this is a beautiful construction. Okay, let me use another color here. So it's equal to 1 over 8 raised to the power of minus 2x minus 1. Wow, I like this. It's a good construction. Okay, so let's try to see what we can do with it. Okay, so this is going to be, first of all, we will try to change this mixed number into a fraction. That's is going to give us an improper fraction now. Okay, so let's bring down this one, which is 2 over 3 to the power of 3x over 2 multiplied by 1 over 6. So if I change this, I'm going to have minus 3 over 2x. Of course, that x can come up here and join your 3. So you have minus 3x over 2 is equal to, here you will now have 1 over, here is, let's still leave this one the way it is. Just open the bracket. If minus multiplies this, you have minus 2x. And if it multiplies minus 1, you have plus 1. So let's just leave it there. Okay. So alternatively, we can actually do this way. Sorry about that. You know, this thing is is 1 all over 8 to the power of a negative power. So this minus 1 can actually go, then the power will change to positive. Thank you for thinking about that, Sapresh. That's beautiful. Okay, so what can we do here now? So what do we do here now? So we will try now to, okay, to here we have minus. The powers are the same now, but we have minus. I remember I said something about fractions, that when a fraction is raised to a negative power, I said it in the previous class, say you have a over b to the power of minus n, that you can write it as b over a. Just turn that fraction upside down and then change your power to positive. So I'm saying that because of this. So here is going to be 3x over 2 multiplied by, now instead of having 1 over 6, I will have 6 over 1. Or raised to the power of, the power will now become positive, and that will be equal to 8 to the power of 2x minus 1. I love this. I really do. Okay, so what will happen next is that my powers have now become the same. So I can now gather the bases in one bracket, which is 2 over 3 times 6 over 1, all raised to the power of 3x over 2 is now equal to 8 to the power of 2x minus 1. Remember, I've not done anything more to the right hand side because I need to get the base, the single base on the left hand side. So see what will happen. 3 will cancel 6 here to give you 2. So you just have 2 times 2, which is 4. And 4 is the same thing as 2 raised to the power of 2. Okay? And everything is raised to the power of 3x over 2. So at this time, I can now move my 8 to the base of 2. And that will give me 2 to the power of 3. That 3 will multiply the existing base, which is 2x minus 1. Alright, so see what will happen now. This 2 here will cancel these 2. So we just have 2 to the power of 3x equal to 2 to the power of, you open this bracket, that will give you 6x minus 3. Okay? Equal bases can disappear now. And when they go away, so your powers will now be equal. So you have 3x is equal to 6x minus 3. So since 6x is bigger than 3x, or I can do it anyway. So let 6x come over here. That will be 3x minus 6s, which will give me minus 3x is equal to minus 3. So the minus will cancel the minus. Therefore, my x alone is 3 over 3, which is equal to 1. Wow. Let me clap for myself now. This is a beautiful run from exercise 1 down to exercise 32. Wow. And if you stayed with me up to this point, I love you. Yes, I do. it means that you are good to go. Okay, so that is the spirit. Must learn to give attention to exercises. You must learn to give time to solving problems, not just 1, 2, 3. I'm telling you the truth, this was what built me as a student then in JSS 2, JSS 3, down to SS 1. I used to have my teacher then as my other brother, who would always have a little time. But what we usually do is that he would just do small teaching and will bombard me with exercises. I will solve and solve. That is why you go to textbooks. You see, textbooks will give you few examples and many exercises. The reason is because it is the exercises that gives you the strength that you need to claim that you have understood that particular topic. All right, so this is what we have for this particular class. Okay, so this is 30 down to 25, and then here is 24 up to 17, and then the other page is where we did 16 down to 12, and then the other page we did 11 down to 1, and that is what we have, exercise 1.6. all right, so this is where we end it for this particular section of our exercises, marathon exercises in mathematics concepts. We started with indices, and then we will continue to other topics of maths. Thank you, and I will love to see you in other videos. I also have other videos apart from live videos that you can watch on the channel. Check the playlist, and then thank you very much. Kindly subscribe to our channel. We'll see you in the next class. Bye.